Beneath 20 kilometers of ice in absolute darkness, at pressures that would crush a submarine like a tin can, there is an ocean. Not on Earth, 628 million kilometers away, orbiting Jupiter, a moon called Europa. And this ocean is not small. It contains twice the volume of water as all of Earth's oceans combined, 2 times, on a moon 1/4 Earth's size. And here's what keeps NASA scientists awake at night. That ocean has been liquid for potentially 4.5 billion years. 4.5 billion. Earth's oceans have only been stable for 3.8 billion years, and in that time, life exploded into every possible niche, from the deepest trenches to the shallowest tide pools. So what has had 4.5 billion years to evolve in Europa's ocean? We don't know. We've never seen beneath the ice, never sent a probe into those waters, never sampled what might be swimming in the dark, but we have evidence. Disturbing evidence. Evidence that Europa's ocean is not dead, not frozen, not sterile. Tonight, you're going to discover why Europa might be the most likely place in our solar system to harbor life, and why that possibility is absolutely terrifying. Because if something is alive down there, it's been evolving in the dark for twice as long as anything on Earth. Europa's surface is a frozen wasteland. Temperature, -160 degrees Celsius. The ice is not smooth. It's fractured, scarred, covered in reddish-brown streaks that look like wounds. Scientists call them lineae, cracks in the ice crust that run for hundreds of kilometers. But these aren't just cracks. They're evidence of something underneath, something moving. In 1997, NASA's Galileo spacecraft flew past Europa and took detailed images. What scientists saw defied explanation. Sections of ice that had broken apart, rotated, and refrozen in different positions, like puzzle pieces shuffled on a table. They called these chaos terrains. This can only happen if the ice is floating on liquid, water. Galileo's magnetometer detected something else. Europa generates a magnetic field, but not from an internal dynamo like Earth's core. Europa's magnetic field is induced, created by a conductive layer beneath the surface interacting with Jupiter's massive magnetic field. The only substance conductive enough, abundant enough, and at the right depth: salt water, an ocean of salt water. Scientists calculated the ocean's depth, 60 to 150 kilometers deep. Earth's deepest ocean point, the Mariana Trench, is 11 kilometers. Europa's ocean could be 10 times deeper, with 2 to 3 times the volume of all Earth's water. And it's been there, liquid, for potentially the entire history of the solar system. But here's what makes it horrifying. That ice shell isn't just a frozen lid. It's a barrier, blocking out sunlight, trapping whatever is below in perpetual darkness. And yet, the ocean hasn't frozen solid. Something is keeping it warm. Something is heating Europa from within. Let me explain how you heat an ocean without sunlight. Europa orbits Jupiter every 3.5 Earth days, but Europa isn't alone. It's locked in orbital resonance with Io and Ganymede. For every orbit Europa makes, Io makes exactly 2, and Ganymede makes exactly 1. This is the same resonance that powers Io's volcanoes. But on Europa, the torture is different. As Europa orbits Jupiter, the planet's immense gravity, 318 times Earth's mass, pulls on Europa's near side harder than its far side. This creates tidal bulges. But because Europa's orbit is slightly elliptical, these bulges don't stay in the same place. They flex. The ice shell rises and falls by up to 30 meters. 30 meters, the height of a 10-story building. Imagine being on Europa's surface. Twice every 3.5 days, the ground beneath you rises 30 meters and falls 30 meters. The ice cracks, fractures, grinds against itself, and that friction generates heat. Scientists calculated the tidal heating, approximately 1,000 terawatts. For comparison, all of Earth's internal heat flow is 47 terawatts. Europa generates 20 times more tidal heat per unit mass than Earth generates from radioactive decay. And all that heat goes into the ocean. But tidal heating doesn't just warm the ocean, it creates something far more important: hydrothermal vents. Just like Earth's deep ocean vents, cracks in the seafloor where superheated mineral-rich water erupts from the mantle below. And on Earth, these vents are oases of life. Earth's hydrothermal vents support ecosystems that don't rely on sunlight. They use chemosynthesis, bacteria that extract energy from chemicals like hydrogen sulfide. And these bacteria form the base of a food web. Tube worms, crabs, fish, octopi. Complex ecosystems in total darkness, powered entirely by chemistry. Europa has the same conditions: tidal heating, a rocky seafloor, water in contact with rock, chemical reactions, energy gradients. Everything you need for life. Except we don't know if life is there. We've never looked, never sent a probe beneath the ice, never sampled the water. But the evidence keeps mounting. In 2012, the Hubble Space Telescope detected something that changed everything. Water vapor erupting from Europa's surface. Not just trace amounts, plumes, geysers of water vapor shooting 200 kilometers into space, high enough to reach the International Space Station if it were orbiting Europa. And these plumes weren't isolated events. Hubble detected them multiple times between 2012 and 2017. Europa's ocean is breaking through the ice. Scientists analyzed the plume composition using spectroscopy. Water, yes, but also salt, sodium chloride, table salt, the same salt in Earth's oceans. Proof that Europa's ocean is salty, conductive, and in contact with minerals from the rocky mantle. But there was something else in those plumes, something that made astrobiologists stand up and take notice. Organic molecules, complex carbon-based compounds. Not definitive proof of life. Organic molecules can form through non-biological processes, but the building blocks of life, the chemical precursors. And in 2018, scientists reanalyzed old Galileo data and found something they'd missed. Galileo flew through a plume in 1997. At the time, they thought the anomalous readings were instrument errors. But when they ran the data again, knowing what to look for, the signature was clear. Galileo sampled Europa's ocean water 25 years ago, and we didn't realize it. The data showed molecular hydrogen in the plume, H2. Molecular hydrogen is a high-energy food source for microbial life. On Earth, entire ecosystems are based on hydrogen-eating bacteria. Europa is venting food into space for free. But here's the truly disturbing question. If Europa's ocean has had 4.5 billion years of liquid water, energy from tidal heating, chemical nutrients from the rocky seafloor, and all the building blocks of life, what stopped life from starting? Or worse, what if it didn't stop? Let's imagine the Europa Ocean. Let's descend through the ice and see what might be waiting. You drill through 20 kilometers of ice. The pressure builds. The light from the surface, already dim through Jupiter's radiation-blasted ice, fades to black. And then, you break through. Into an ocean 100 kilometers deep, completely dark. No photosynthesis, no plants, no algae, just chemistry. But in that darkness, there could be vents. Cracks in the seafloor spewing superheated water at 300 degrees Celsius. And around those vents, in the temperature gradient where hot meets cold, there could be bacteria, archaea, microbes extracting energy from hydrogen, methane, sulfur compounds. Simple life, microscopic life, like Earth 3.5 billion years ago. But Europa has had 4.5 billion years. Earth went from single-celled organisms to complex multicellular life in 600 million years, from fish to land animals in 100 million years, from small mammals to humans in 65 million years. What could evolve in 4.5 billion years of uninterrupted ocean? With no mass extinctions from asteroid impacts, Europa's ice shield protects the ocean from cosmic bombardment. With no ice ages, the tidal heating is constant. With no competition from land-based life, there is no land. Just ocean, just vents, just darkness, just time. Could there be things more complex than bacteria? Things that swim, hunt, sense their environment through bioluminescence or electrical fields like deep-sea fish? Could there be an entire ecosystem we can't imagine because it evolved under completely different selection pressures? Earth's deep ocean has horrors we're still discovering: vampire squid, gulper eels, anglerfish, creatures that look alien because they evolved in the dark, under pressure, away from sunlight. Europa's ocean has had 3 times as long to create its monsters. And we would have no warning, no way to prepare, because when NASA finally drills through that ice, and they won't know what's down there until they're in it. What if there's something larger than bacteria, something that sees the drill as prey, as territory intrusion, as food? We're planning to send a probe into an ocean we've never sampled that's been isolated for 4.5 billion years. That could contain life forms that evolved along completely different lines than anything on Earth. And we have no idea what we're going to find. In October 2024, NASA launched Europa Clipper, the largest planetary science spacecraft ever built. Solar panels the size of a basketball court, 9 scientific instruments, a mission budget of $5 billion. Its goal? Confirm that Europa's ocean can support life. Clipper will arrive at Jupiter in 2030 and perform 49 close flybys of Europa, coming as close as 25 kilometers above the surface. Its ice-penetrating radar will map the ice shell thickness. Its magnetometer will confirm the ocean's conductivity. Its spectrometers will analyze the composition of those plumes. But Clipper won't land, won't drill, won't touch the ocean. It's a reconnaissance mission, a scout, gathering data to determine if we should send something deeper. Because if Clipper finds definitive evidence of habitability, or worse, hints of biological activity in the plume samples, NASA will have to make a decision. Do we send a lander, a drill, a submarine? The European Space Agency is already planning JUICE, the Jupiter Icy Moons Explorer, which will also study Europa. And NASA has proposals for a Europa lander mission, a drill mission, a cryobot that melts through the ice and deploys a submersible into the ocean. But here's the ethical nightmare. Earth life is tenacious. Bacteria can survive in spacecraft clean rooms. Spores can survive radiation. If we send a probe into Europa's ocean and it's contaminated with Earth microbes, we could destroy an alien ecosystem that's been evolving for 4.5 billion years. Or worse, what if Europa's life is more aggressive than Earth's? What if we bring something back? The mission has to be sterile, completely sterile, no Earth contamination, but achieving that level of sterilization while maintaining functioning instruments. Scientists don't know if it's possible. We're standing at the edge of Europa's ocean, and we don't know if we should jump in. Right now, 628 million kilometers away, beneath 20 kilometers of ice, an ocean is moving. Tidal forces flex the ice shell, cracks propagate, plumes erupt into space, venting water and organics and energy. And deep below, at the bottom of that ocean, hydrothermal vents might be pulsing with superheated water, minerals, chemicals, energy. Is something down there using that energy, swimming through that darkness? Has life found a way in Europa's ocean like it found a way in Earth's? We're going to find out. In 2030, when Clipper arrives, we'll have our first real answers. We'll know if Europa's ocean is habitable, if the chemistry is right, if the energy is sufficient. And if the answer is yes, then we'll have to face the possibility that we are not alone in our solar system, that life doesn't need sunlight, doesn't need Earth-like conditions, just needs water, chemistry, and time. And Europa has had more time than Earth. More time for life to start. More time for life to evolve. More time for life to become something we can't imagine. The ocean is waiting. And soon, we'll know what it's been hiding.